viewers and learners of the Postgraduate Diploma in Environmental and Occupational Health. The course code for this course is MEV 004 and it deals with environmental toxicology. I introduce myself as Dr. Sushmita Bhaskar, working in the discipline of Environmental Studies in the School of Interdisciplinary and Transdisciplinary Studies, Indira Gandhi National Open University. The first lecture will deal with the introduction to environmental toxicology. So we have all been exposed to several pollutants. They may be from the air, from the water, the soil pollutants, and some of these, including drugs which we use for the therapeutic use, even that can have a toxic action on the human body and human health. Some of the toxic substances can be biotransformed and they can be detoxified and then eliminated from the entire body system. But some of the toxins or the toxicants, they can be really toxic in nature and they can bring about systemic or organ toxicity. Let us now see the different toxins and the toxicity and definition of the various terms involved in environmental toxicology. The quality of our environment is decreasing day by day. And as I said earlier, we are being exposed to different toxins every day. So all these toxins, and all these pollutants, it could be from the air or the water, they could create and they could have acute, chronic, subacute toxic effects. That means some toxicants, they could immediately cause a kind of an acute toxicity. Some of them could actually take a long-term effect and then you could even have chronic ailments. The learning objectives of this module would include the definition of toxicants, environmental toxicology, ecotoxicology, bioaccumulation, biomagnification. Then we will also know and understand about the history of the toxicology and the toxicants. And then finally, we will also learn and understand the terms which include chronic toxicity, subacute or acute toxicity, and also the terms which include the threshold dose and the dose and the exposure, how these are also important in the toxicological studies. Now coming on to bioaccumulation and biomagnification. Living organisms like human beings, they can be exposed to the toxic substances at any stage of their life cycle. So we may be exposed as children, as adults, or at any stage of our life, we could be exposed to several kinds of the toxicants. Now these toxic things or the the toxicants, they can be accumulated in the organs or even in the fatty tissues and they can be bioaccumulated. So the concentration of that toxicant also matters to a very great extent. How much of the concentration of that toxicant is stored in our body. Biomagnification. Now in the food chain, okay, you have the herbivores, the carnivores, the omnivores, and at the producer level, the predators, the consumers, and so on. So you have this food chain, and in nature we have a large number of the food webs which are interconnected with the different food chains, and this operate in nature. And the human beings are at the top of the food chain. So for example, if the fishes, if any toxicant is accumulated at the plant level or even at the fishes, for example any toxic metal, let us take mercury for example, they can be bioaccumulated in the fishes, in the tissues of the fishes, and after that when the higher animals or the mammals, it could be even the birds, when they eat the fishes, then a certain increased amount, then it is magnified in those birds. Then when human beings are consuming the final product, then again the concentration of these toxicants will be still more biomagnified in the human being. So at each level the concentration of that toxicant will be biomagnified, and the final person, that is the human beings at the top of that chain or the web, they will then be affected to a very large extent. And this classic tragedy occurred in Minamata, that is in the Japan, where the people had a strange neurological and neurotoxicological syndrome by consuming the mercury contaminated fishes, and this was then biomagnified, and they had several of the neurological disorders and paralysis, numbness. They had several other problems related to their health. Now let us go on to the historical development of toxicology. So this started very early in the human civilizations. For example, the cave dwellers, they identified plant and the toxic extracts, and these were actually used in hunting and in warfare. Then the earliest medical works of Hippocrates, of Aristotle and of Theophrastus, they were published during the 400 and the 250 BC, and they include the mention of the word poisons. Scriptures and records in the ancient period, they indicate that by 1500 BC, hemlock, opium, arrow poisons and certain metals, they were used to poison the enemies and also for the state executions. The notable poisoning victims, they include Socrates and Cleopatra and also Claudius. The study of Paracelsus in 1500 AD and Orfila in 1800 AD, these are very important in environmental toxicological studies and this discipline especially. Paracelsus, so he is one of the founders of modern toxicology, and in his study he showed that specific chemicals were responsible for the toxicity of a plant or an animal poison. He introduced the concept of the dose-response relationship, which is a very important concept in toxicology. So he said that all substances are poisons. It is the dose that makes the poison. Therefore, dose is very important and that determines the toxicity or the hazardous nature of the substance. The dose is the actual amount of a chemical which is entering the human body. Now, the amount of exposure and the type of toxin will also determine the toxic effect. So, let us take the example of the medicine or the therapeutic drug aspirin. This is also known as acetyl salicylic acid. This is relatively safe at recommended doses, but the chronic use, this causes deleterious effects on the gastric mucosa, and it is also fatal at about 0.2 to 0.5 gram per kg. In many of the countries, as before, even in 1985 or so, aspirin has been banned, but in some countries it is still being used. Before the toxicity of it can develop, a substance must actually come into contact with the body surface. For example, it should either be ingested, it should be inhaled, or it should be ingested and absorbed in the human system. So it could be that the toxicant has to come in contact with the body surface, such as your skin, the eye, or the mucosa of the digestive or the respiratory tract. Now, an acute exposure, this occurs over a very short period of time, usually 24 hours or so. Chronic exposure, that means this is occurring over a long period of time. It could be weeks, months or years. This example I would like to give in industrial settings, which are occupational hazards. For example, a person who is exposed to a certain chemical or a hazard in an industry, then it is a chronic exposure to that toxicant for long periods of time, over weeks or even over years. So therefore, dose response is a relationship between exposure and health effect. This can be established by measuring the response relative to an increasing dose. This relationship is important in determining the toxicity of a particular substance. So the basic concept is a dose or a time of exposure will cause an effect on the exposed organism. Usually, the larger or the more intense the dose, the greater the response or the effect. This is the meaning behind the statement, the dose makes the poison. Now that is why, for example, doctors, when they prescribe, any kind of a medicine, they look at your body structure and the weight of a person, the age of the person, and then accordingly the dose is being administered. Even if it is paracetamol, whether you require 250 mg or 500 mg or so on. So the dose is actually determined according to many factors, and then it is established and then given to a patient. That is why you should never take over the counter prescription, that is OTC, or you should never overdose yourself without knowing how much of that particular chemical or the medicine is required by the body. Threshold dose. This is a dose or the exposure level below which the harmful or adverse effects of a substance are not seen in a population. This is referred to as the threshold dose. This dose is also referred to as the no observed adverse effect or the no effect level. Now these terms are often used by toxicologists when discussing the relationship between exposure and dose. Now we go on to the term individual susceptibility. Now there can be difference in types of the responses to hazardous substances between people. Now as I told you, for some people, some may be oversensitive to certain drugs or certain medicines or even certain food that you eat. You could be even allergic to certain kinds of food, and that can also be toxic to some people and it may not be toxic to another. So that is called an allergic reaction. The same way, in some person an exposure can cause no effect, while in a second person that person may become seriously ill, and the third person may also develop cancer. So this is referred to as individual susceptibility. That means a certain kind of a toxic substance or a toxicant will have differences in different individuals. In the 18th century, Ramazani's Diseases of the Workers was published in 1700. He is also known as the father of occupational medicine. Now Hill also in 1761 said that a nasal cancer and snuff use is correlated. You have seen that many people, they use this snuff which becomes a habitual use, and then they are not able to get rid of this. So this snuff, when it is used over a period of time, then that causes nasal cancer, not only there because it is getting absorbed and going inside your system, so it can create cancer of even certain other organs. Now the incidence of scrotal cancer among those working in the chimney sweep, this was also observed by Percival Pott as early as 1775. So here you see that many of the occupational hazards and those substances which are used by people in daily life, that can also cause incidences of cancer or toxic effects. Orfila, he is often referred to as the founder of modern toxicology, and he was a Spanish physician who worked at the University of Paris in the early 19th century. Orfila showed the materials, or he in fact analyzed the materials that showed the effects of poisons on specific organs. He was the person who identified toxicology as a separate science, and he published the first book on toxicology in the year 1815. In the 20th century, descriptions on the DNA were also given. This led to an advancement of knowledge on the toxic effects of substances both at the cellular and the DNA level. The Silent Spring, this was a landmark publication by Rachel Carson in 1962, and this influenced the modern environmental toxicology. She is also known as the mother of environmental toxicology. Rachel Carson, now her book actually served as a catalyst for the establishment of the US Environmental Protection Agency, and she is regarded as the mother of the environmental movement. So her book actually challenged the practices of the agricultural workers who were then using DDT, and then she saw that how the birds were getting affected and they died in the process. So DDT, which is an organic chlorine compound, and this then remains in the food chain, and it is a persistent organic compound which remains in the environment for several years. So she was the one who challenged the practices of these workers, and from then the environmental movement has been in full swing. So recently, with the advent of molecular techniques in biology, detailed studies have also been done in toxicology and xenobiotic metabolism. Some more definitions and concepts. How do we define environmental toxicology? So this deals with the harmful effects of the physico-chemical and biological agents of organisms. In the same way, ecotoxicology, this deals with the harmful effects of toxicants at the ecosystem and at the population levels. Toxicant, this is any material or substance that is hazardous and poisonous, and it could also be man-made and artificial in nature. Toxins, these are produced naturally by some organisms. Toxicologist, they are scientists who study toxicants and toxins. Xenobiotics are the foreign substances which are entering the body. This is derived from two words from Greek, xeno meaning foreigner, and of course biotic, which we all know, which is life and the study of these. Xenobiotics are the foreign substances which are entering the human or the animal systems. Toxicosis, these are the diseases that are produced by a certain toxicant. Tolerance, the definition of tolerance, we can say that the ability of an organism to show less response to a specific dose of a chemical. LD50. Now these are also very important terms which are used in the discipline of environmental toxicology. The dose that is lethal to 50% of a test sample or a population. So in this diagram you can see LD50 toxicity, where 50% of the population dies and 50% of the population lives. Basic concepts of toxicology, we again have the concepts known as systemic toxins and the organ toxins. Systemic means after entering the body, this will affect the entire body. For example, potassium cyanide. So this you will all be familiar, even in case of certain people who are working for certain organizations. They don't want their identity to be known, and they are caught by the governments or in any such kind of a situation where they are cornered. Then you would often see that they don't want to reveal the truth, and then they just take a pill which is tied to their neck. So this is often the cyanide capsules, and this can affect each cell and organ, causing immediate damage and death. Organ toxins, these affect the specific tissues and organs. For example, benzene, this will target the blood forming tissues. Lead, this will target the central nervous system, kidney and the blood or the hematopoietic system. Now this is an example and the figure which is showing that for systemic toxicosis, you see that the entire system is affected, where the blood vessels are being affected, and even in the eyes, the blood vessels, you can see the reddening of the eyes and the how it gets affected in the process. Selective toxicity. This means that a chemical will produce injury to one kind of living matter without harming or giving any kind of a toxicity to any form of other form of life, even though the two may closely exist with each other. This is often seen in the plant species. There can be a chemical and they may be placed very close to each other, but one plant will survive that effect, but the other plant will not be able to cope up with that adverse effect, and then that dies in the process. So that is selective toxicity. Agriculture and toxicology. These are the possible health effects from exposure to the pesticides or the herbicides, or the effect of the animal feed additives such as growth factors on several people. Occupational and industrial toxicology. This is concerned with the health effects from exposure to chemicals in the workplace. They also strive to protect the workers, that is this discipline, protect the workers from the toxic substances and make their work environment safe. So that is why these days in several of the factories and organizations, there is an environment department, an R&D department, environmental engineering, and there people conduct the several trainings also every week or once in 15 days. There are also safety procedures and protocols that have to be practiced and followed by all the factory and industrial workers. Food toxicology, this we are all very much familiar with. Certain substances, they add the food additives and the colorants and so on, or there could be also food adulterants. In recent years, we have had the example of a certain kind of the noodles, which said that it had a higher content of certain heavy metals, or it had some kind of a food enhancing flavor. So what was all that about? Because that it was not in the prescribed limit, or it was in that concentration which was something which was more than the permissible limit that the body can actually take up. So that is why that product was banned for some time, and then after the revised food regulatory rules, and the authorities took a look into the matter, and then they came up with the new product. So food toxicology, there may be certain substances which are added to the food to make it look good, taste and smell better. That is why it is always good if you can avoid those artificial coloring agents. All of these additives, they may produce adverse effect. They can also cause certain food allergies. That could be like the pista flavor, the vanilla flavor, all these are just colorants, and they may give that food flavor and enhancing effect. Now certain people naturally, they may be intolerant to lactose or even to gluten. In that case again they can have certain food toxicosis. That is why these days we are having the food grains and even the wheat which is gluten free, and also the milk also which is lactose free. We have the soya milk and the soy products which even the lactose intolerant and the gluten intolerant people, they can consume the same. In the same way, heavy metals also, I give you an example of the noodles where the heavy metals are found in the food. They all can be toxic to the human bodies, and food can also be a route which can cause toxicosis in the human people. Clinical toxicology. Now this term is very specific, and this is concerned with the diseases and the illnesses that are associated with short term or long term exposure to the toxic chemicals. Finally, we come, now that we have known all the terminologies related to environmental toxicology and toxicants, I would like to conclude by saying that the toxic deposits and their effects, that is all these toxicants and the toxic substances, they could be deposited in each part of the system. In the following lectures, we will have a detailed account of every organ and how these are, like for example, we will deal with the nephrotoxicity, with the neurotoxicity, that is in every organ, how specific toxicants can affect that specific organ, bringing about organ toxicity. So therefore, these toxicants can cause, they could be deposited and be accumulated in the central nervous system, in the fatty tissues, and in the kidneys or in the gastrointestinal tract, and all this, it can cause the central nervous system disorders, unexplained weight gain, disorders in your hormonal activity. There could be inflammation and stiffness in the joints, there could be loss of memory, there could be blurred vision, acid reflux, risk of breast cancers, irritable bowel syndrome. This is a very common feature of the toxic syndromes, and also there can be risk of colon cancer. So in recent years, we have seen the incidence of breast cancer and colon cancer is on the rise. So we need to think that this was not so prevalent in the earlier times. Our forefathers, they did not have so much of percentage of the breast and the colon cancer, but these days this is very much prevalent, and it is time for us to think, what are the factors responsible? Are environmental factors really responsible for the incidence and the high prevalence of these diseases? So by summarizing the lecture for this session, we have discussed about the environmental toxicology, the history of the environmental toxicology and toxicants, and the very important people, for example, Paracelsus, the Orfila, and also Rachel Carson, who have been instrumental in promoting the field of toxicology, and how certain environmental movements also then took place. And we have also seen the several concepts related to the toxicological studies. For example, the dose exposure concept, the threshold dose, individual susceptibility to several toxicants, and then we have also seen how the toxicants can bring about systemic organ toxicity, and where these toxic substances could be deposited in the body and cause their effects. I hope I was clear in explaining the concepts. Thank you for your patient listening.